Okay, hi, this is Saka, and I'm helping Honors with their homework. So I'm going to go through each question, kind of give you like a hint or an overview so you kind of know hopefully how to do these questions when this is all said and done. So for number one, you have the frequency of a photon is 5.92 times 10 to the 10 to the 14th hertz. What's the wavelength? So with this one, we have all we need to do is we need to use C equals lambda times nu. Okay, and we're solving for wavelength. You have nu, so C over nu will give you lambda. And so, whoops, darn it, I pressed too hard. And you should be able to just plug in your numbers and solve. Since there's nothing, since the answer is going to be in meters and you already have it in hertz, which is 1 over seconds, you don't have any conversions to worry about for this one. So moving on to question 2, let me scroll that puppy up so you can see it. So a certain photon has a wavelength. What is the energy? So again, ultimately we want to use E equals h times nu, but we can't use it because we have wavelength, not frequency, not nu. So what we have to do first is we have to solve for nu. So C over lambda equals nu, and then what we have to do then is solve for. So we're going to use this equation first, and then we'll use this equation second. Okay, so there's no conversions to worry about this time. For number 3 here, remember what you know about the color spectrum. So remember we talked about Roy G. Biv in our homework the other day. So just as a review, remember this end has low frequency, so low nu. This end, the violet end, has high frequency or high nu. This end has low energy. This end has high energy. This end has uh, high wavelength. This end has low or short wavelengths. And as we go from red to violet, these will increase, whereas this other one will decrease. And knowing what you know about these colors now, hopefully that'll make a little bit more sense. Moving on to number 4. All right, so for this one, for number 4, we have something that normally appears green in white light. So here we have our green object. And remember, the reason why this works is because um, green is reflected back to our eyes. Everything else is absorbed. Now if we change the scenario here and we only have red coming in, well, remember, every other color besides green gets absorbed, so this gets absorbed. And if this is absorbed and this is the only source of light, there's nothing coming back. So there will be no color coming back. So what do you think, what color is no color? And I'll leave it at that. Kind of give that one away, but you kind of need to know how to do it. Okay, moving on to question 5. Let me turn my page here in my little notebook. So for number 5 here, as a little hint, okay, what colors are necessary to produce white light? I'll just give you this one. So it's red, green, and blue. And the reason why is because your eyes basically see these 3 colors. So your eyes, if they see all 3 colors at the same time, it overwhelms your eyes in detecting, so it looks like white. So your eyes are easily fooled. Okay, 6. All right, ionizing radiation. We talked about this today when we talked about the photoelectric effect. So this is this idea where we ionize. So electrons leave. Remember when we had the light shine on the metal today? The photoelectrons were emitted. That's ionizing radiation. And basically anything UV or stronger in terms of energy can ionize. Oops, that does not look like can. Can ionize. Okay? So anything you see on that list that's stronger than UV is capable of being ionizing radiation. Okay, anything that's weaker than UV, which includes visible light and below, cannot ionize. Okay, question 7. So why is UV dangerous? UV ionizes. Okay, and this is what's so dangerous, because if it ionizes, if it ionizes um, cell molecules, if UV light causes them to ionize, it causes damage. And if it's specifically DNA, we're talking about cancer, which would make everybody sad. Okay? And seriously though, the idea here is that the ionizing radiation damages your cells. The other ones are just silly questions, silly options. Let me turn my page so we can finish this puppy up. Okay, electron. So question 8 is basically another ionizing question. So you're looking for ionizing electromagnetic radiation. And we just said that was UV or stronger. All right, moving on to number 9. All right, a sweater appears blue. So if we have a blue sweater, so here's our blue sweater. Let's pretend it's a turtleneck since I can't draw. And they have uneven sleeves. So here we have a blue sweater, which really looks like a plus. I don't want to hear it. Again, the idea here is that blue is reflected. And all other colors other than blue is absorbed. And hopefully you'll be able to figure it out from there. There's no scattering or anything crazy like that that goes on. That makes no sense. Okay, number 10. Scrolling up here. Okay, so we have helium, okay? Helium has its fingerprint, right? And this is the, gosh darn it. And this is the atomic emission spectrum. It doesn't matter where the helium comes from. It'll always have its unique fingerprint. It'll always be identical, no matter where you get it from. And the last one, okay. All right, so 11, we have 87.2 joules of energy. And we have the wavelength. The wavelength is equal to 5.39 times 10 to the minus 7th meters. Okay, and it's asking for moles of photons. We'll actually do this together later. All right, I'll give you some hints on how to do this problem. This is total energy. Okay, when we solve for E equals h nu, this is the energy, darn it, this is the joules in one photon. Okay, so if we solve for the joules in one photon, we can divide to figure out how many joules or how many photons make this many joules. Probably have no idea what I'm talking about, but to do this really quick, first thing you need to do is you need to use the wave equation so to solve for nu. So C over lambda equals nu. So this is the first step. Okay, then you solve for E. So E equals h times nu, which is step 2. This is the weird part. Okay, you're going to take this answer in E. So E, the units is actually joules per one photon. That's the actual unit. Okay. In step 3, what you would do is you take 87.2 joules over 1 and then you'd go you take the inverse. So it would be 1, yeah, 1, yeah. So you do 1 over your answer from E, the reciprocal of E, and then you'd multiply by 1 mole over 6.02 times 10 to the 23rd photons. I know it seems weird, but this is how you would do it. I know for those, some of you are going to be able to figure it out already based on this, but for those of you who can't, we will go over this problem tomorrow first thing. So I'll see you all, and have a good night.